This is lesson 6.6, complex fractions, elementary algebra. Complex fractions are basically a fraction that has more than one fraction. So for example, 1/2 over 2/3. Alright, so what we've got here is a fraction, line right here, with a fraction here and a fraction here. So really, one of the ways you can look at this to determine if it's complex or not, which it doesn't really matter if it is how many lines you have. If you have more than one fraction line, then it's a complex fraction. Here you have 1, 2, 3. Okay, so I made this one longer so I could say 1/2 divided by 2/3. If you remember, you don't divide fractions, you invert and multiply. And that gives me 3/4. So that's how you solve a complex fraction. Alright, let's keep looking at some of these because they aren't all that spiffy easy. So let's look at example 2 here. In example 2 we have 2x cubed over y squared, and then I make kind of a bigger line there to show my fraction line, over, what is that, y to the 5th. God, my eyes are bad. Alright, so then we take the bottom one and we flip it over, and this part here goes away, and then we can start canceling. So we can cancel this one x here with one of these x's, and that means we have 2 left. 2 of these y's with 2 of these, which means we have 3 left. So that gives me 2x squared times y cubed, and when you multiply them, you just stick them together. And that ends up being our answer there. Once we put it over our 4, and then we can cancel the 4 and the 2 because 2 over 4 is the same as 1/2. So then that gives me x squared y cubed over 2. And that is my answer for example number 2. Alright, let's look at example 3. Okay, so before we can do this one, we have these two that are added and these two that are added. Before we can go across this big division line here, this has to be one fraction and this has to be one fraction. Here we have basically an x over 1 and a y over 1. We have two fractions here. So we have to combine these and then combine these, then we can go across this big line here. Okay, so let's just look at the top. Okay, common denominator, if you look, what am I missing here that I have here? Well, I'm missing a y, so I'm going to put a y there and a y there. And the other one, I have a y here, I'm missing a 1. 1 doesn't really matter. So this fraction now can look like this. xy plus 1 over y. So now I've got one fraction there that I'm going to replace that with. Okay, let's look at this one. I have y over 1 plus 1 over x. Alright, what am I missing here? I'm missing an x. So I'm going to put an x here and an x here. And over here, I'm missing a 1, but that doesn't matter. So now I'm going to put these together, and I'm going to get xy plus 1 over x. So that is a simplification of my denominator. So let's write them as I have them. xy plus 1 over y, so that's my numerator, over xy plus 1 over x, and that's my denominator there. Now I have one fraction on top, one fraction on the bottom, so now I can invert and multiply. So let's do this in blue. I'm going to put my numerator down the same, and now I'm going to multiply by the reciprocal. So I'm going to flip this over. Okay, now, one of the things that's important is I can cancel across like this, but I can, like this here, because of that plus, it's grouped together. So if I'm going to cancel anything, I have to cancel the whole stinking thing, which in this case I can. I can cancel that with that, and that leaves me with an x on top and a y on bottom, and I'm done. So not too terribly scary. So let's do 2 more examples and then we'll be done. Okay, so there's example 4 written out. And again, like I said in the last one, we have to make this one fraction and this one fraction before we can do anything with the 2. So let's take the 1 minus 4 over x squared, and we'll put this 1 over 1 so we have a denominator. And I look and say, alright, what am I missing here that I have here? An x squared. So I'll put an x squared here and an x squared here. Over here I'm not missing anything because I've just got a 1. So then that will turn into x squared minus 4 all over x squared. Because my denominators don't change, they're just common. Alright, now let's look at this one. This one's going to be a little bit trickier. 1 over 1 minus 1 over x minus that. Alright, so let's see what I'm missing. What am I missing here? I'm missing an x, I'm missing an x squared. So x squared is my biggest one, so that's what I'm going to put down. And what am I missing here? Well, I've got one x, but I don't have the second x, so I'm going to put an x there and an x there. So now I have an x squared when I multiply those. Here, I'm not missing anything. So my final result then will be x squared minus x minus 6 all over x squared, because again, those don't do anything. Okay, so now I just replaced that with that and that with that. So let's write this. Over okay. Now, since I have one fraction here and one fraction there, I can invert multiply. So let's go ahead and do that. Move some stuff out of the way here. Okay, so that's going to equal x squared minus 4 over x squared times, I'm going to flip this over, okay. Now, I can cancel both of those with both of those, and I'm left with x squared minus 4 over x squared minus x minus 6. Alright, so before I end though, I have a difference of 2 squares that can be written as x plus 2 and x minus 2. And this here can be broken up into 2 binomials, so don't forget to do that. Let's see, I've got a 3 and a 2. That is a negative and that is a positive. Remember, I know that's a negative because that's a negative. The biggest number is always this sign. Now I can cancel some more. I can cancel that with that, and I'm left with x minus 2 over x minus 3. Okay, so that's my answer for example 4. Alright, we're going to skip example 5. I thought that was another complex fraction, but that has to do with sequences and the Fibonacci sequence, and we're going to skip that. So let's go ahead and look at the problem set on page 378, 6.6. And you've got 15 to 29 odd, so those shouldn't give you too much trouble. Just keep doing what we're supposed to be doing. In fact, let's do 29, just so you have an idea of what's going on there, because those don't have fractions, but they do have, I mean, they don't have complex fractions, but there are fractions there, and they may be a little bit tricky when you look at them. So let's go ahead and do number 29 there. We have, in fact, we'll just do that on the next video. Well, how about that?